In this video, we will talk about what is the use of static keyword in C#. Now this question probably looks very basic, and if you ask developers, most of them will end up saying that it is used in factory patterns, it is used in singleton pattern, it is used for sharing data, etc. But I think patterns are just the byproducts of static keyword, and the existence of static keyword was for three basic purposes. In this video, we will unleash what those three basic purposes are. Now, in order to understand the use of static keyword, let's consider this simple project here called as some application. Okay, it has two class libraries. One is the customers and the other one is the masters. The masters library has a simple class called as country master. It has three properties: country code, country name, and computer name. Now the country code is nothing but it will have the three-letter symbol which represents a country, and the country name is nothing but the full-blown textual name of the country. The computer name has the current machine name. So the insert function, right? You can see that there is also insert function. The insert function inserts the country record into database, and while inserting, it also uses a computer name property to tell from which computer this record was inserted. Now the second library, that is a customer library, has a simple customer class here, and you can see that this customer class has three properties there. So the first property you can see is the customer code, the second property is the customer name, and the third I'll not say it's a property, but it's a it's a simple variable, that is a machine name. Okay, you can see also there is a isEmpty function there which actually checks if the string is empty or not. So in other words, if you see the isEmpty function, it actually takes a value, and in case if there is no value, it just returns true, saying this is empty, or else it returns false. And you can see there's a function there called as public void insert. Now this insert function actually goes and inserts this customer class into database. So before inserting, it checks if the customer code and customer names are empty, then it will not let the insert happen, or else it will let the insert happen. The problem with the customer class is the machine name. Now this machine name actually has it should have the current computer name while inserting this customer record into database, so that we can track from which machine this customer record was inserted. Now if you remember right, our country class had our country class had the logic by which it actually goes and retrieves the machine name. So rather than writing a duplicate logic over here, we would like to go and use that logic so that we don't need to write redundant code, or we don't need to write duplicate code. Now in order to consume the computer name logic, right, what we'll do is, let's go to the country master class here. Now you can see that the get computer name logic, the logic which gets a computer name, this property is actually private. So in order to consume this function or this property, right, in the customer class, we need to actually make it public, or else it won't be available, right? And secondly, now let's say the two properties of the country master, that is country code and country name, right, we would like to check if these two properties are empty or not. So while we are inserting this function, we would like to check if these two properties are empty or not. And what we would like to do is we would like to use, or we would like to reuse the isEmpty function of the customer class. So rather than writing the complete logic again, right, in the country class, we would like to reuse this logic here. Now again, you can see that it's a private function. So what I've done is I made it as public. So in other words, what has happened is the country master class had a very nice logic which actually gets a computer name, and that logic we wanted to use it in the customer class. So we made that property as public. And in the same way, the country master wanted to consume this isEmpty logic here, the isEmpty check logic. So we made this as public. Now while we did this, right, we violated encapsulation. Okay, let me make you understand what exactly happened. Now in order to understand the violation of encapsulation, let's go and consume both these components, or both these classes, that is customer and masters, in our project called as some application. Now this some application is nothing but it's a command line application. It's a simple console application. And let's go and import both the namespaces, that is customer as well as our country, or as well as our masters. Okay, now let's go and create a simple customer object, as well as let's go and create a country master object. Okay, so let me just go and create here an object called as oCustomer. So new customer class, and in the same way, let me go and create a country master object here. So oCountry is equal to new country master, right? Now let's go and try to see the properties of O customer. Yeah, now that's very interesting to see. Now you can see that there are some properties which comes from .NET here, like equals, get hash code, get type, to string. So we won't talk about that, but let's talk about properties and functions which are exposed by us. So you can see here we have exposed customer code, customer name, insert, and is empty. Now there is a clear violation of abstraction here. Abstraction means that show only what is necessary. So external person who is consuming your customer class, what should he see? He should see customer code, great. He should see customer name, well understood. He should see an insert function, well understood. But the is empty function is not understood. I mean to say, a customer component or a customer class, when somebody is using it, what is the is empty function doing that? What exactly it is meant for? So what's happening is your customer class its abstraction, the abstraction what is exposing it to the external world is now confusing. Okay, so that's one big problem here. In other words, as we were making the functions public, right, we have violated encapsulation, or I'll say rather our abstraction is not so simple as it should be. In the same way, things are also not good with the country master object now. So let's type O country and let's see the properties here. So you can see, like well understood, that a country class or a country object should have country code, it should have country name, it should have insert function. But somebody who is using a country class, he has no idea why a country class has a computer name or a machine name. So in other words, again, because this computer name, we made it as public, we violated encapsulation, and because we violated encapsulation, now the abstraction doesn't look so simple, right? So in other words, what has happened is, we have increased reusability, but as we increase reusability, we have started violating the basic object-oriented principles. In other words, our country class is now showing a computer name property, which can be very confusing at times. And in the same way, our customer class is now showing out a is empty property, a is empty function, which again can be very confusing. So how do we solve this? So the answer is pretty simple, just create one more class library or a project library and move those two functions in that class library. So let's go and create a simple class library here called as utility. Okay, and what we'll do is, in this class library, we'll go and move both of these functions, that is the computer name, the logic which gets a computer name, as well as the empty check function. Okay, so here's our utility class. Let's give a nice class name to this, saying common routines. So this common routines, is nothing but, it's a class, which will have these kind of unrelated functions, which we would like to reuse, in many of the classes, and also we would like to preserve our object-oriented principles. So let me go and take this computer name from here. I've already taken the isEmpty function. I've already moved the isEmpty function here from the computer class, from the customer class, and also I have moved the computer name logic here, right? Let me just make this as a function here so that it looks more better. So you can see now that both the logic, both these functions, which were causing the problem of abstraction, which were causing the problem of encapsulation, we have moved them into a separate class library called as utilities, and we have clubbed them into a class called as the common routines class. So now let's go and reference this utility class in both the customers as well as the master library over here. So right, now let's first start with the customer class, and let's go and import the utility namespace here first, so that we can start using the customer class, start using the utility classes here. And now let's go ahead and create the object of common routines class. So if you remember, right, the common routines class actually belongs to the utility namespace. And let's go and invoke the isEmpty function, which belongs to the common routines class. So I'm going to say isEmpty, and again we'll say oCommon.isEmpty, right? Perfect. So common.isEmpty. So you are seeing that we are now able to achieve reusability. Second, the insertion should happen only if it is not isEmpty. So let me just go and correct this logic here. That's a wrong logic. So not. Okay. Now, okay, let's go and build this. Right. right? So all fine looks like, so 4 succeeded. Now the next important point here is that we need to go and flourish the machine name variable using the common routines class, right? So let's go ahead and use the common routines to get the machine name and flourish the machine name in the customer class. Now this machine name variable will flourish inside a constructor. So as soon as the customer class object is created, we'll flourish the machine name. So let's go and define a constructor here. You can see I've defined a constructor here called as customer class. And inside this, again, let's go and create the object of common routines and flourish this machine name with the current machine name. So common, and inside this machine name, I'll just say get computer name. Perfect. In the same way, now let's go ahead and modify also the country master class. So we have imported the utility namespace. So what I'm going to do is I'm going to directly go and I'll keep the same structure. That is, I'm not going to go and change the computer name property. So what I'll do is, I'll just go and create the common routines class, and wherever it was using that return system.environment.machine name, I'm going to go and just invoke the common routines class here. So I'm going to say routines.get computer name, so that the complete code is centralized in the utility class. And in the same way, now also now I can use the the isEmpty function. So I just need to go and create the object of common routines again here. So let me just go and say here common routines and routines is equal to new common routines, right? So I can now say routines dot isEmpty, and we want to check the isEmpty for the country code as well as country name. So let me first check for the country code, as well as I'm going to check it for the country name. So routines dot country name, routines dot isEmpty country name, right? So now I can see that because we have centralized our our code inside the common routines class, I can reuse this code both in the country class as well as I can reuse this code in my customer class. So in that way, I have not violated encapsulation. So my country class as well as my customer class both are maintaining their sanity, and also I have made a cleaner solution, by introducing the utility class. So this is a perfect solution. So there doesn't, this solution doesn't look any weird. It's a decent solution. I'm sure many people would agree to it. But again, there are some concerns here. So let's talk about those concerns. Now, in order to understand the problem in a better manner, let's first speak about this utility class more. In other words, let's try to analyze, this utility class in a better manner. If you closely watch, right, the utility class is a collection of methods, functions, and logic which are unrelated. In other words, for example, you saw in the current scenario, the get computer name and the isEmpty functions are completely unrelated. They don't have any connection with each other as such. So you can think about, it's a utility class which can have anything in the world. Now, because it has unrelated methods and functions and logic, right, it does not represent any real-time objects. In other words, when we talk about object-oriented programming, or when we talk about classes, right, classes actually represent some kind of a real-world object. But here, because we have made the utility class, in order to see that we don't have redundant code, and in order to ensure that the customer class and the the master class, they do not violate encapsulation. They are pure. That's why we have created it. So because of these unrelated functions and unrelated methods, right, this utility class does not map to any real world object. Okay. So that's the first point to note here. So now if you say that, this utility class is a collection of unrelated methods, it's a collection of unrelated function, it's a collection of unrelated logic, it does not represent any kind of real world object. What it also means is that any kind of object oriented principles, should not be allowed to be applied on this utility class. In other words, nobody should be able to inherit this class. Nobody should be able to create interfaces, or nobody should be able to apply interfaces over this class. The abstract keyword, the abstract classes, that should not be allowed on this class. Polymorphism should not be allowed on this class. Why? Because this class, it does not represent any kind of real world object. Okay. So in simple words, what we are saying is that this is a fixed class, a class which has a fixed behavior, whose behavior cannot be changed by inheritance, whose behavior cannot be polymorphized, by using a dynamic polymorphism or static polymorphism. So what we are trying to say is that, this class is a fixed class. or I'll say rather this class is a static class. So now the question is, how do we avoid inheritance? How do we avoid interfaces? How do we avoid abstract keyword, over this class? And that's by using the static keyword. Now, in order to make this class as static, we need to use the static keyword here. So just mark it as static. Now, if you make a class static, right, all of the functions, the variables, everything inside the class should also be static. So we need to actually make the isEmpty function as well as the getComputerName function as static. So which I've already done here. And once you compile, right, you'll get a lot of errors here, and the most significant error is that you can't use anymore the new keyword on the common routines class. So you have to invoke it by the class name and then dot the function name or the method name, whichever you want to invoke. And that is but obvious because because this is not a real world object, it doesn't make sense to use the new keyword on it, right? So by default what happens is internally only one instance of the static class is created, which will actually go and serve any clients who connect to him. Okay. So let's go and delete this new keyword and directly use the class name of the static class, the class name of the static class, and straightforward will invoke the functions here. So you can see that I'm replacing each method here. So common and straightforward the class name, method name, that is isEmpty. So let's compile this and everything looks fine here. Good. So what we have done is, first part is we have went ahead and we have made the class as static, and because the class is static we also need to make the functions and the methods as static. We did that, and once we compiled it, we got error stating that you can't use the new keyword, and that is right. Why? Because it's not a real world object. So to invoke the functions we have to say class name dot directly the function name, and which we did, and now we have compiled the complete project and it looks okay, right? And now just out of curiosity, we would like to see that if any object-oriented principles actually works on this common routines class. Okay, so let me first try with inheritance. So let me go and create a class here called as my own common routines, and let me try to inherit the common routines class, and let's see if this works or not. So in other words, all those principles of object-oriented programming should not be any more applicable to this class. So you can see that it's clearly showing me error there saying that you cannot inherit the common routines class. Why? It's a static class. So if you try to build this, let me just build this. So you can see clearly the error saying that cannot derive from a static class, which is your utility.commonRoutines. So right, so inheritance doesn't work on this. Good. Now let's try some other things like interfaces and abstract classes. So let me go and delete this. So inheritance doesn't work. Let me go and try to create an interface, and let's see if interfaces work on this class or not. See, if interfaces are working on this class, then again what it means is polymorphism will work, dynamic invocation will work, etc., right? So here you can see I've created an interface I1, and it's straightforward saying me that no, static class cannot implement interfaces. Great. So it's stopping all those object-oriented programming concepts to be applied to the static class, right? So that's great. So interfaces don't work, inheritance doesn't work. Let me try the abstract keyword. So can we make this as abstract class? Because if we are able to make this as abstract class, or which we cannot, right? Because as I already said, so you can see that static classes cannot be abstract class, right? So you can see that most of the object-oriented programming concepts are not applicable anymore to this static class, and which is what we want, right? Because this class common routines, it does not map actually to any kind of real world object. It is just a collection of unrelated functions and methods or logic, so that we can increase reusability in our project, or I'll say we can increase technical reusability. So it's a technical object, but it's not a real world object, and it makes sense that any of those object-oriented principles are not applicable to this common routines class. So now we are in a better shape. So our utility class is now in a nice shape. So probably tomorrow nobody can do inheritance on this, nobody can apply polymorphism, and with this any kind of bad design will be avoided. Okay, so good. But there's one big problem here. The problem is, at the end of the day, it's a class. So you say that okay, we cannot apply inheritance, we cannot apply polymorphism, we cannot apply interfaces. Great, but at least to use that class it has to be instantiated, right? If it is not instantiated, you can never invoke those functions and those routines, right? So how do we go about instantiating this object, or how does the instancing or how does the instantiation of this utility class actually takes place internally? Now, in order to overcome this problem regarding instantiation, right, what the CLR runtime does is it creates one instance of the static class. In other words, in our current scenario, the utility class which has been used by both customer class as well as the customer master class, right? Country master class, right? Irrespective how many times this utility class is called, right? There is only one instance of the object who is going to serve each of those clients. So in other words, new instances will not be created. Okay. Now, because of this single instance behavior, right, of static classes, the static classes also are, they are also used in scenario when we want to share common data. Okay. So for example, let's say you want to share configuration data in your Windows application. So let's say you have 50-60 forms, and every time those forms actually run, you would like to share some common data. So what you can do is you can make a class as static, right? You can make the variables as static, and what will happen is only one instance of the object will be created in the memory, and thus all the forms can share the common data. So the instantiation problem is solved by creating only one instance of the object. So always remember that static classes has only one instance of the object created in memory. Now let's try to see if only one instance of the object is created or not, right? So what we'll do is let's go to a common routines class here, and let's create a simple variable here called as some kind of a counter variable. Okay, and this counter variable will be incremented every time either the customer class or the master class actually invokes the common routine methods. Okay, so I've created a how many times called as an integer variable here. Now as I said that you cannot have simple instance members inside static classes. You have to have those members as static. So we need to say this cannot be simple public int. Okay, you have to say it as public static int. So let's do that, and let's build this. Right, great. Now what we'll do is this how many times variable, right, will increment every time whenever we call this isEmpty function, or we call the get computer name function. Okay, so let me just say here common routines dot how many times plus plus, and in the same way let me go here and say common routines dot how many times dot plus plus. So every time you invoke a function over this common routine, I'm going to go and increment this variable. Right, good. Now let's go to our some application. Let's go to our command line application which we have created, and let's invoke these functions, that is the customer methods as well as the master class methods. Okay, so let me go and first reference both these classes here, and let's go and import the namespaces. So now what will happen is every time the insert is called for both customer as well as the master classes, right, it will go and increment the how many times counter. Okay, so what I'll do is I'm going to go and also let me take the utility class here, because I'll need the utility class to display what is the value, right, the current counter value, how many times value. Okay, so let me go and first create the customer class and invoke the insert function. In the same way, let me go and create the master class, and let me go and invoke the insert function. Okay, now irrespective, the customer object is new. You can see that new keyword over there. The country master object is new, but inside, the utility class, the common routine class will have only one instance running. So every time that how many times plus is added, right, it will actually go and accumulate on the same. It will not go and refresh the values. Okay, so in order to ensure that, what we'll do is let's go and display the how many times value here. So you can see that I have called the insert 3 times, one for the customer class and once I have called for the masters, right? So it should the how many times should show me the number as 3. So in other words, if it is using the same class, right, if it is using the same instance, then it should actually go and just increment the value over it, rather than refreshing it. Okay, so what I'll do is I'm going to just go here and say display me this how many times value. Okay, so what should happen is I should see now the value as 3. So okay, and 3 means that the common routines has only one instance of the object running in memory. So let me build this. No errors, good. And right now, okay, that looks fine. Also let me do a read line here so that we can see what the value is, or else it will just go and it will just go off. Oh, there's some problem. I'm sorry. Let me see what the problem is. Let me debug this. Insert. Oh, right. You can see that I'm saying value.length equal to 0. I have not handled nulls. So on nulls you can't go and invoke the properties like this. So let me go and fix this up here. So before I check, even the length is equal to 0, or rather I'll use a string function here. So what I'll do is I'll say string dot check it is null or empty. So either it is null or either it is empty, right? This will throw up exception, right? Because remember that nulls are different and empties are different. Okay, they are not the one and the same. So let me now build this. Now I don't think I should get a null exception. I have handled it, and let me run it. So I should see the value as 3. Why? Because 3 times inserts are called. So even if they are called from different classes or different instances, you can see that the value is 3. So what it says is, what this signifies is that only one instance of your common routines class exists, and that instance how many times variables is updated, rather than refreshing the values. So this proves that only one instance of the object is created, for the common routines class. Now because only one instance of the object is created, what it also signifies is that the constructor will run only once. So which is again very important point to note. So what will happen is, the time you call the first method, the first time any client calls the first method on this common routines, right, it will create an instance, and after that the constructor will never run. So the constructor also will run only once. So if you see this, now I've created a constructor here on the common routines class, and I have put a debug point. Okay, if I run this, right, let me just run this. Now this is the first invocation happening on the common routines class, that is get computer name. So you can see that the constructor is running there. Now after this, the constructor will never run. Why? Because only one instance is created, right? So you can see now, for example, when I'm calling the insert, again I'm calling isEmpty function, and again I'm calling isEmpty function for customer name and customer code. But you can see that it's not going and invoking the constructor now anymore. So the constructor also runs only once. Why? Because only one instance of the object is created in memory. So this is again one of the very important point to remember about static class, that the constructor runs only once in a static class. Now because of the single instance behavior, static classes are also good candidates for caching data. Now in order to understand how we can implement caching using static classes, let's go ahead and create a simple collection here, a simple collection of string, and this collection will have weeks, like Sunday, Monday, Tuesday, etc. So in this collection we'll actually store the weekdays. Now I do understand that collection objects are not good candidates for storing weekdays. Probably enum should be a good candidate or a good choice, but for now, for the cache demonstration purpose, we will use this collection, and this collection will be flourished in the constructor. So you can see that I've created a simple constructor here of common routines, and in that constructor we will actually flourish the weekdays, that is Sunday, Monday, etc. So let's go ahead and add the weeks into the O weeks string collection. So Sunday here, and let me quickly go and put Monday, Tuesday, Wednesday, Thursday, because Friday, right. So you can see that I have actually flourished the collection in the constructor of common routines. Now as we know that only one instance will be created, right? So this collection will run, this constructor will run only once, so it will not run again and again, right? And let me write a simple for each loop, which will actually go and browse through the string collection and display the weeks onto the console application. So for string str in common routines.o weeks collection, and we'll just do console.write line here. Right. Now you can see that, okay, I've started already the debugging. I've already started the application here. You can see the constructor runs only once, and after that, this O weeks actually is cached into in memory. So after that, anytime you go and browse the O-weeks, right, using the O-weeks collection using the common routines class, it will always come from the in-memory cache. It will not come, it will not be flourished again and again. So again, because of, you know, the what you call the single instance nature of static classes, it's also a good candidate for caching purpose. So now let's summarize, let's put together what exactly, you know, we have learned in this 30 minutes video. So summarizing, there are three important use of static keyword. First one is it helps you to group unrelated functions and methods together. So for example, like a utility class. Second, you know, because static variables are, you know, because only one instance of the static variable is created in memory. So definitely if you want to share common data across class libraries, or if you want to share common data across forms, right, static objects are very useful. A third one is, you know, if you want to cache data. So for example, let's say if you have a country master, you know, so rather than going and hitting the database again and again, you can load the country master into a static variable or a static list or collection, and then you can just go and look up the list again and again, you know, rather than making a round trip to SQL Server or to your RDBMS. So these are the three important use of static keyword. So I hope that you enjoyed this video. So next time whenever you see a static class or a static method or static variable, you know, you understand in what kind of scenarios they are useful and in what kind of scenarios they fit in. So I hope that you enjoyed this video. You know, keep visiting questpond.com for such kind of videos. Thank you very much.